Hello, this is Mrs. Hedden on Chapter 14, Notes 4, where we cover last night's WebAssign. The first problem was a 3.5 gram lead bullet traveling at 450 meters per second strikes a target, converting its kinetic energy into thermal energy. Its initial temperature is 40 degrees C. Find the available kinetic energy of the bullet. Okay, and again, we always start by writing down what we know, the velocity, the mass. Make sure you convert that mass to kilograms, what we're hunting for, the kinetic energy, and then the equation you're going to use. And of course, the equation is very straightforward. It's 1/2 mv squared, and we plug it in and we get 354.38 joules. Now this part was easy. It just required using an equation from last year, so you need to remember it. The second part, which comes in, is a 3.5, find the heat required to melt the bullet. And for that part, we are going to have guest lecturers. In other words, in period 3, I want Brian and Brian to whiteboard and present the problem, as well as Sarah and Francisco. So you might have two different alternative ways of solving it. All 4 of these people got it correct. In period 6, Catherine and Mason will whiteboard and present, as will Albert and Jacob. Again, all 4 of these people got it correct. So you will have that after the video. Next. Okay, the formation of condensation on a glass of ice water causes the ice to melt faster than it would otherwise if 8.7 grams of condensation forms on a glass containing water and 240 grams of ice. How many grams will melt as a result? Assume no other heat transfer occurs. Use the heat of vaporization of water at 37 degrees as an approximation in this problem. So again, we write down the things that we know. The mass of condensation, which could also be called the mass of water, the mass of ice. We're hunting for the mass that melts. And it says to use the heat of vaporization equal to 37 degrees. Now, the energy or heat from condensation should equal the energy of fusion from melting. That's conservation of energy. So the mass of the water, or condensation, times the heat of vaporization should equal the mass of ice times the heat of fusion. I got the heat of fusion from table 4.2, the heat of vaporization at 37 degrees from the footnotes, number 5 and 6, at the bottom of the page, which are identical footnotes for some strange reason. So we get the heat of vaporization, 580 kilocalories per kilogram, the heat of fusion, 79.8 kilocalories per kilogram. Plug it in, and we get 63.23 grams. Notice because I have grams on either side, I did not convert to kilograms. I certainly could and probably should have to make my units all work out, but I would have had 8.7 times 10 to the negative third on one side and and whatever mass times 10 to the negative third on the other side. So it all works out because we have mass on both sides. So the mass that melts is 63.23 grams. Now, the rest of you can go ahead and start working on the other problems while your guest lecturers whiteboard the second part of the first one and then present it to you before the end of the period, which Mr. Kimball will arrange. Thank you very much for your time. And by the way, the guest presenters are getting extra credit. Talk to you later. Goodbye.